Let's settle down quickly so we can start the event. How many of you are coming for the first time today? Alright. How many of you belong to AIML field up to any extent? Alright, and rest of the people are like me who don't know anything about that, right? Alright, good morning again, and again weather is the culprit today, so we are seeing some less attendance. Yeah, but last time when we met, India were yet to win the World Cup. India is still not won the World Cup, right? But last month again when we met, Diwali and New Year was yet to come, and it has done very greatly. We all enjoyed that vacation, and I would like to wish everyone a very happy New Year on behalf of every one of us. Right? Again, we are into the fifth chapter of our AI Vision Community India. This is our fifth presence at this place in particular. And as a part of this community, this is the third event. And if some of you are not knowing about this event, like we are part of global AI community, which has over 36 or 37,000 members actively participating in it throughout the world. So it is a very global community and is connected in all the different countries of the world as well. So we are also a part of that community, and that is ever expanding. About today's session, if I talk about, again, you have got two very intelligent speakers. One is Mr. Shuvam, who will start the proceedings first. And as we move forward, again, I would like to inform you about these things. Turn off your mobile phone. If it is not on silent mode, you can put it on silent mode, or you can just switch off it. Maintain silence while speakers are speaking. Ask your questions anytime by raising your hands. Enjoy the meetup and enhance your knowledge, and make new friends and have snacks at the end of the event. Alright? If some of your friends are still waiting or they have still not come, you can just make a call to them and ask them to come ASAP. Now I would like to hand it over to our first speaker, Mr. Shuvam, who is having around 4 years of experience into this AIML field. His background is in EC. He is from EC background. He is having a strong knowledge in hardware related stuffs as well. But since last 3+ years, he is constantly working on AI and ML, and more specifically on the computer vision subject. Right? Let's give him a big round of applause.
Am I audible? Thanks. Okay. Okay. So our topic for today is pose estimation and ancestor recognition. So we'll be going over these topics, like why are we using pose estimation, where it all started, and how can you implement it into your applications, right? And we'll be having a demo such as well. Okay, so what is pose estimation in itself? So pose estimation, just look at the diagram. So what do you feel from the diagram, right? I would like to have the audience answer that. What do you understand by pose estimation? Any idea on it? I like to make this as a bit interactive.
I think the is about motion and movements is different type of poses.
Yes, that is one of the applications that we do. Any idea how can we go there? Any idea from the picture itself?
What will be the next?
Yes, we will predict the person. Okay, so if you look at this specific picture, it is actually having the joints of the bone. If you look at it, so it actually predicts that. With that, after that, if you know the movement, right, you can obviously recognize what is going on and not, right? So how do we get these points right? What makes it different, right? So whenever we train a model or whenever we see from our eyes, like they are going to be having some distinctive features, right? Like if your hand is gonna have a wrist, right? Then you have a hand. Then you have one ankle. Then you will be having ankle and elbows, right? Then you will be having your thighs. Then you will be having your hips, right? So those are the things that will remain constant over a period of time if someone moves or anything like that, right? So pose estimation can there are two types of pose estimation. Like there are 2Ds and 3Ds, right? So in 2D, what we can do is like we have one single camera and we define it. It can be an image, it can be a video, but we take it as frames, right? Like a single camera, and then you can find the pose of that person, find the key points of that person, and then you can link them together and find the person itself. Like you will get a skeletal structure out of it. Just like if you look at here, like we will get a skeletal structure out of it, right? So in 2D, we have just a single camera. The other thing comes into place is like something called 3D. If you look at the image behind me, you see a 3D space, right? And this person is moving. So what we see here is we are just viewing it from a single camera. But to actually do this, you need actually multiple cameras to be actually set up, right? So this is one of the still the most challenging task that we have till date in pose estimation, because having multiple cameras at different angles at different places, right? And then having them linked together is quite a challenge, right? So for this session, we'll be mostly discussing about 2D, not 3D. This is one of the, if someone has gone through LinkedIn, this is one of the very most interesting project that is there right now in 3D. So this guy actually used three cameras for actually getting the spatial coordinates. But then again, he had a specific room, he had a specific camera at some specific length. So everything was very specific. So that's why it's quite easy to, not easy, but comparatively easy to do this, right? And another thing, there is just one person. That makes computation very less, right? Okay, so why do we want to do pose estimation? So first of all, it started in 1960s to around 1970s, because people wanted to do human computer interaction, right? So you don't want to touch a computer. You are already interacting with your computer using your hands, like you have keyboards and your mouse, those are your input devices, right? People did not want to touch them. They wanted to, let's say, I want to do like this and the slide will change. So those kind of interactions, right? So that's why this all got started. Because nowadays, this application has moved very much forward. Now we have robots do stuff for you, then you have elevators do stuff for you. Like you do this and the elevator opens, right? There has to be some kind of gesture. Works via sensors also, but gestures make it more specific, right? So this is kind of a timeline that will go through how pose estimation was actually done, right? Because it has been very many years, like how I discussed, right? We are going to identify the joints and everything, right? But we can't directly identify the, at some time during 1990s, you did not have a computer vision algorithm this strong which would make it such, right? So we'll be going through those. And till today, what we are using the latest ones and how you can use it in your applications as well. So in the 1990s, we had something DLTs and PNPs. So anyone working with 3D cameras would know PNP. So DLTs and PNPs almost similar. PNP uses ransack and actually is highly computative. What it actually does is anything in the real world will have a 3D coordinate, right? It will have a 3D coordinate starting from somewhere, you take it as 0, 0, right? And when you click a picture of it, it will have a 2D coordinate in the picture itself, right? You have a picture which shows the 2D space. It has no depth, right? But then what you do, you can compare it. Like you have your 3D space, 3D coordinates, and you have your 2D coordinates in your image, right? And then you make a linear transformation out of it. You write a linear equation so that you know that any point in 2D space is something in 3D space. But to do that, you need to actually compute the linear algebraic equation by computing, let's say, this point is in 3D here. In the image, it is somewhere else. After getting around 200 points out like this, you generate a linear equation out of it so that you can inverse anything on the 2D space can now be mapped to a 3D space. Not very accurate, needs multiple cameras to at different distances, very computationally expensive, right? After that, in 2000 and 2010, we had iterative closest point. So what they were trying to do was like same again linear algebra, but right now first we are doing in 2D and 3D space, making a linear equation out of it. Now we are doing 3D space and 3D space. Like take a camera here, and I can see this person from here, and take another camera from there, and I see that person over there, right? Draw a point cloud out of it. Like let's say any distinct features, those are hand drawn. Like let's say where's the face, where's the nose, where's the lips, right? And then make an algebraic equation to actually compare two 3D coordinates from different angles, right? Make a linear equation out of that, and then you can have a joining. So if you look at the picture itself, you will see three colors: red, blue, and green. So there are three cameras here where we drew a point cloud, and then we actually made an iterative computation out of it. Still expensive, right? Then we have something called ASIC. Very streamlined. So if you look at this, we wanted to actually detect this person here. It's like very specific. It will not work for all, but it was a model that was developed, right, for human faces. We already know how a human face looks. We already have a basic idea, like it's gonna have a circle, then we are gonna have 2 points, then a mouth, something like that, like a smiley face. And then what you do after going through multiple iterations, like this is the person, this is the image that I wanted to converge at, and this is the thing, this is the the initial pose that I have, like the initial thing that I have, so which will converge actually. Then I make some get some features out of it, like what are the contours out of it, what are the boundaries, because if we learn computer vision algorithms, we know that we can find the edges out of it, right? So there's those edges and these edges are actually compared, and after that we get something like this. So this will get a kind of a converging model, and we know, right, this can be used. Still, very specific use case. It does not work with if the guy is looking left, right. So then you have to have multiple ASMs, like not very useful in real life. In 2010, we already started having computer vision models at a good stage, and something we are doing with feature extraction, right? So shift and surf is one of the most wideliest used in feature extraction. We also have orb and other things, but these are two most popular ones, right? If you look at the image here, so we wanted to actually make a point cloud out of this, and we wanted to match this, right? So I take it from a different camera, I take it from a different angle with a different camera, or the same camera, doesn't matter. Preferably a same camera. Then what we do is we match the points all together. Like this point is actually this point is actually this. Heavily computed algorithm also uses the first algorithm, PNP, that we discussed, right? So it takes into point, it actually solves it by using that same PNP. Then we match the point all together. Then we get a transformation out of it, right? This can be used for humans, but still does not work with, let's say, the human is here and you take an image from the back, right? It's not going to work because features are not going to be the same, right? Occlusion comes into place. Then we have right now what still we do not use convolution neural networks till date, right? Till 2010s we just had feature extractions. Feature extractions are done by CNNs, but not ready. We are not training the CNNs itself. So after 2010s we had CNN actually do it. It's neural networks actually getting trained on it, right? So this was this deep pose. What you see, deep pose was one of the most which was a turning point for actually pose estimation, because right now we just use features, right? Now what this used to do, instead of features, it would directly infer the joints of your of the human, right? And look at that. So this is one of the pipeline that is used for deep pose. So you put in an image, then it finds the confidence maps and the affinity fields. Then what it does, like this is sorry. This is the open pose, because deep pose only works for one person, open pose works for multiple persons. Okay. So one of the things that needs to be considered, because we'll be looking at some algorithms also which are very much faster if there is one person. Because when there are multiple persons, then you need to infer, the inference becomes hard, right? So this is the first part where we had CNN, right? Nowadays, what we are using is much more. I think many of the people have used it also. So these are the things that we use right now, like media pipe, YOLO V7, YOLO V8, and YOLO NAS. YOLO NAS is still in process, still being benchmarked, right? So and media pipe to YOLO V8. YOLO V8 is right now the best model that you can have for processing. Computation is expensive, but it is the best, most accurate one. So MediaPipe. MediaPipe is proprietary by Google. It is closed source, but you can use the model, and it is very fast. It is very fast in the sense MediaPipe is used in your phones as well. If you remember, when you say "Hey Google" or any other things like that, everything runs on MediaPipe. It is a proprietary thing by Google, and it is quite fast. One of the things why most people use MediaPipe is for this reason actually. MediaPipe has some limitations, we'll go through it. Like it can only do for one person. It has two stages, runs through detection, then tracking. It first detects a person, one person at a time, and then it will do the key point estimation out of it. 32 key points works on place post 32 key points. There are multiple models out of it. So this uses the place point thing. Okay. Very fast. It is so fast that without any optimization and anything in your code, you can run it at real time. You will say if you have an i5 computer, you can run it around, let's say 10 to 15 FPS easily, no issues. One of the things why video pose is also used can be used in edge devices and mobile devices also. Like the thing I said, Google already uses the voice recognition thing in using media pipe. Okay. So this is very fast. We can also integrates wonderfully with TensorFlow line. It actually uses TensorFlow line over there. So you can integrate in your, let's say, if you want to make an Android application where you want to detect poses, right? MediaPipe is your go-to option. Like if you just take one person first of all, okay. And means like you can use it in edges also. Means like let's say you want to set up an edge device, a camera, and an edge device, edge computing device, and you want to compute in that. And let's say you do not have much computing power right now. So MediaPipe is your go-to. Then we had YOLO 7. YOLO 7, yeah, works on multi-person single stage. It does not do detection, key pointing at two different stages. You directly give it to the image, it will directly find out the respective key points that you want actually. And it will already link it together, like this is for person 1, this is for person 2. So you don't need to do any kind of sorting according to that also. Very fast, 17 key points, very accurate also. But there are some cases in which it does not work. Let's say you have two persons walking together, occluding each other. You will see the key points of one person shifting to another person. This thing happens, right? To make this better, this was created. We had YOLO V8. This is right now one of the best models that are there right now. Works with multiple persons, still single stage, 17 key points as YOLO V7. Successors to YOLO V7, much faster, much accurate. Means like right now, even if you have two occluding humans, it's gonna infer the poses correctly. And YOLO V8 has also started Tiger. It's like a human pose estimation is just having the joints of the human, right? This model also supports training it on different animals. Like someone did it on tiger, and YOLO V8 now officially supports tiger. Like it's still in development, but it officially does, right? Like there are other models also if you want to train other than human, but we are focusing mostly on humans here. Okay. And this gives you a edge, right? If you want to train something else, if you want to try something else, you can go with YOLO V8. Easier to train, the pipeline is easy. Right. We get into applications. So for applications, what we have is like, what can we do with pose estimates? You have the pose of a person, right? Then you can do this video analytics or sports analysis. Like you see a person playing, you want to know how the person plays, what is his jump height and everything, right? Another thing that comes into place is whenever you are, let's say, You have a match tomorrow with a different team, right? You know who is your opponent, right? You want to review that team also, right? You want to know how they play. You want to know what are going through their heads. Like if I give a smash, then how he is going to react, right? If I know how he is going to another thing. You can look through 100 coaches do this. They look through 100 of videos. They depict how that other team performs under pressure, how they move, right? But there are still cases, right? How much can a human go through with 100 videos? You can't find patterns, right? You'll get it. Good coaches can find good patterns. Now let's say you don't have a good coach. You put in a pose estimation model. You write in a code. You find how a player performs, right? So you can get a analysis of it, right? You can get data, right? Data is worth in gold if you know how to use it, right? A good coach can use the data, right? You see how that player performs and you can make your team suitable against that, right? Can be used highly useful in basketball, badminton, table tennis. Anywhere you have very many movements of the human body, right? Second, we have AR and VR immersion. Right now, the AR and VR space that we have, like using Oculus and everything, you have two handheld devices, right? So that actually tells you where your hand is going. Then you have your, if you want to know where your legs are going, then you have another system for. Instead of that, just put in uh, that Kinect. There is a module called Kinect which you connect to your PS4 or your Xbox, and it is a camera by itself, right? So the whole thing that you are doing by using handheld devices can be done using pose estimation, right? You have one camera, it will take your pose out of it. You don't need to have handheld devices, right? So the cost comes down, the software cost goes up, but the hardware cost comes down, right? Very useful application. After that, we have surveillance and security. I wrote something called gait recognition. Gait means the style of walking, right? Someone said, right, you can predict someone's movement, right? So gait is something like that. Every person moves, it has a specific style, right? Everyone knows. You can mean like, let's say it is dark out there and you see someone coming, you know that that is your friend. How do you know that? Because you know his style of walking, right? So that is what is called gait recognition. Very useful in surveillance and security. How? Let's say you get robbed, a bank gets robbed. Obviously, he is not stupid to open his face, right? There are cameras. He knows there are cameras. How can you find that? Let's say whenever the guy comes in, he's gonna walk, run, whatever he's gonna do, right? So it's like the recognition, there is going to be a pattern, right? Find that pattern. We already have security cameras installed in, let's say, uh, in roads and everything, right? Find that person. Obviously, you can't find the exact person. Not very, because gait recognition is still in process of getting made. Like very few people have worked on gait recognition. This is one of the very early movie concept kind of things, right? But you can still narrow down out of like 10,000 people. You can narrow down to like at least 100 or 200 people, right? Then you can go through it. Like the list of suspects become less, right? Then we have robotics. In robotics, you can do collaborative tasks. Right? You will be saying like I can just do it in a click of a button, right? And I can tell a robot to do something. Why would you need something like this? Let's say you are in a high volatile environment where you can't speak. Something, let's say you are going to war or there is a battle going on and you have your robot dog with us. So this is the thing developed by Boston Dynamics right now by USA DARPA. So this is one of the most advanced robotic system that is there right now by Boston Dynamics. Let's say you are in a high world and they are making it for army cases, right? It's like US Army guy has to carry some thousand, like some kgs of load on his shoulder, like put it on a dog or put it on a robot. But let's say you are in a highly volatile system, someone is shooting at you. So what do you want to do? So you can't like shout or do something. Do some gestures, right? Do your pose. The robot's gonna see it. Let's say I need ammo refill. You tell him, he's gonna do it to you, right? You don't need to go and click on your hands and everything, right? Good for collaborative tasks. Can also be used for what do you say? Let's say you are in space and then you want to collaborate with the other robot that is there. You don't want to click any buttons, so you can do that, right? Another thing that I'm mostly interesting, video game industry. Whenever you want to, let's say, make a character model out of it, so you need to have a person. You have to have a person, make them wear a suit, then it will have 100, what do you say, 100 or 200 different points out of it. Then you have 20 or 30, sorry, 100 or 200 cameras surrounding them, and they walk, right? That point cloud that we get, that is actually used they take the soft copy out of it and then they iterate out of it and they make a character model out of it. So this is the character and this is how he is going to move. Instead of putting that suit on and instead of putting like 200 cameras, put in 4 to 5 cameras. Do pose estimation out of it. Get like train that model around 2 to 3 times or more times if we are making a recurrent network, and we can make a model out of it, right? This guy did the same thing, but he used just 2D, and look at the results. You see that there are no his left hand and his right hand are almost same with the character, right? That is business logic. He got the points out of it, and then he is like, if the left hand is shorter than the more than other, then you can write it. Create the same model. He already had a model with it. He just linked the joints together, because that is what we are finding right now, right? The key points itself. Anyone has any questions on pose?
So there is a limitation, like if we say by hand gesture.
Yeah.
So right now, what I mean when we talk about AI ML, so hardware plays a very major role to have
Yes.
that kind of thing.
Yes.
So for now we have the sensors which we use for the hand that are resistance based.
Yes, yes. It's like those are called flex sensors.
We can understand the logic. I mean that laws, and right now sensors are available.
Yeah.
So I mean it will be definitely imposing some limitation of the data transfer or some speed.
Yes.
So how do we solve it like this?
It's like right now, what we do is like, let's say you do it with sensors. So you need to have a, let's you have some gestures and you are doing it to someone else, right? How is the gesture actually communicating? It has to commute via somewhere, right? You need to have someone has a radio guide. You commute through that. Let's see your radio modulates cameras. So then, yes, there are specific use cases. That right now the sensor that you are talking about, it is called a flex sensor. Flex sensor. You can put it here, and if you do this, the resistance actually goes down, and you can see the current actually getting dropped, right? So that sensor is actually very costly if you look at it, right? And another thing is like whenever we we know that most of the around 99% 90% of the problems in the computer vision space that we are working right now can be solved using sensors. Why not sensors? Because you can't you seamlessly integrate. You want sensors. You, let's say whatever the thing you have your glove or whatever, you need to integrate sensors into that. You have 1,000 personnel on the team. You need to prepare 1,000 gloves plus extra whatever backup you want to keep, right? Put in a computer vision model, your cameras remain same, everything remains same, just the software changes, the backend changes, it's a whole new game, right? It's a retrofitting module. Yeah. So it's like using existing things, no changes to the personal or anything, and you are getting productivity out of it, right? Same thing. Any other? Yeah.
You mentioned some models, right? It's the best one, and what are the layers in it?
Okay, so I am not getting into the layers right now because right now we have the best model depends on your use case. Right now, if you want the highest accurate model, you have your YOLO V8 and your YOLO NAS, right? So NAS is still in development, but they released a note that it is faster than YOLO V8 and more accurate, not yet tested, right? No. I'm talking about YOLO NAS. YOLO NAS, Super Greatness by DCI. So you can check that out. So that tells that it has a better accuracy than YOLO V8. Okay. And right now YOLO V8 is the standard model that we are using. It's like computationally expensive, but can be done. But you want to run it on edge devices or something like that, convert it into TensorRT for like NVIDIA engines. For OpenVINO also you can get it converted, right? Conversion takes a long time. That is a lengthy process that happens because once it's done, then the inference rate that you get, like YOLO V8, let's say on your machine i7 it runs at 10 to 15 FPS, right? convert it into TensorRT, put it in a NVIDIA Jetson Nano, and it's gonna run at around 17, so around 20. Let's say 20. Put it in a NVIDIA Jetson Ore, and it's gonna run at 30. So that is it. For the layers, I think you can Google that, and I just here to tell you the things, right? So V8 you can obviously go into YOLO V8's repository. You will find the whole layers out of it. Okay. Anyone else? Yeah.
You have mentioned about
Media byte, yeah.
There are 32 points that it detects.
32 points it detects. Yeah.
So if I need to add any other points, like 33 points, is it
In MediaPipe you can't. The problem with MediaPipe is that it is closed source by Google. You can use the model out of it, but you can't retrain your own. But you can do the same thing in YOLO V7 and YOLO V8. If you want to train it, put your data set in such a way, and it's going to train on it. Possible.
And secondly, I don't have much knowledge about the media type.
Okay.
But just in curiosity, how it actually detects that particular? How?
Okay. How the key point actually gets detected, right? So that comes down to CNNs, right? So let's say whenever we want to okay, so this is one of the sessions I took before. So for CNNs, what we do, let's say we want to detect something, right? So we know what is the input and we know what is the output, right? We give it random weights and biases to actually determine some output. So let's say the value we wanted was 2 and the output I got was 0. Okay, what is the difference? The difference is 2. What is the error? The error is 2. So it's going to take that I have an error of 2. So I need to change my inside parameters that I have. Yes, that properties. Yes, that is that properties. Yeah. So that's the same thing. So the output here is not detection. We don't have X, Y, W, X if we want to do object detection, right? But for key points, what do we have? We have is like 32 points we want to detect. Like 32 point means it will be an array of 32 and it will have the X, Y positions, right? We give it random weights. It gives us random values. The points are going to be different. Calculate the error, that propagate, run it again. Same thing.
Okay, so first we need to use the particular perfect points to the model.
Yes, obviously. That is what is called ground truth, right? If your ground truth is bad, then obviously the model that is going to come out is going to be bad, right? Yeah. Yes.
Application is interesting application, and luckily I got a chance to work from my assignment.
Okay. Yes.
So media I was using the media type of Google.
Yeah.
So just wanted to know, have you ever got a chance to work with thermal images for post
Thermal images, no, because thermal images the data set becomes different because the by default the model that you get that is for RGB images, right? Yes, like if you want to use that for thermal, there I think are data sets available for thermal images also, and you can train your model on. But the problem is with MediaPipe you can't put in thermal images because you can't train MediaPipe, right? Because that is closed source, right? And MediaPipe is fast because it is closed source. If it opens it, right, then the most problem that you get is you are using protobuf libraries in that. And when you build it, it does not use CMake. It uses I forgot the name. There is another instead of CMake which you can make C++ libraries, right? So that is it is quite hard to actually get used to that. CMake is quite easy because whenever you run MediaPipe, it's one of us it's like it converts the model into something else for optimized in CPU. That's why it runs faster, right? The problem with MediaPipe is that only. Is you can run it for an application for a very specific use case. One person, RGB image. You can't put in thermal images, right? But if you want to work with thermal images, I think YOLO V7 and YOLO V8 is a very good starting point. But then again, you need to create ground truth by yourself because thermal, if there are no data sets available, right? Anyone else? Okay, then I'll move to the next topic. A bit short one. We'll have a demo of pose estimation as well, and the next topic as well. But I'll go through it real quick. The next topic, a bit small. Hand gesture recognition. Same thing as pose. Right now, only hands. Right. One of the we'll come into the applications, the library used later because there is not very many libraries that actually work with hand data. Obviously, you can create your own. But let's say for hand gesture, we just have 3 to 4 things for this application, right? Like we have sign language, right? That's the most common one that we're gonna use hand gestures for, right? Then we have gaming, obviously. Anything related to AR, VR, non-interactive, anything making it immersive, you can use hand gestures for it. How can hand gestures be helpful? Let's say that for AR, VR, we are having a Kinect and the whole pose is also getting detected, and for the hand part, you know where the hand is. Crop out the hand, put it in a different model for detecting the hand gestures. You want to do specific things, making it more immersive, right? Like now we have metaverse coming in, right? So in still in development, but let's say you want to do someone like this, you can't do like this, right? You can only do like this. So making it more immersive. Another use case that is quite possible is for industrial use. Like for industrial, there are heavy machineries, right? Now something goes wrong in a heavy, you push a button, you do something else, your hand gets cut off or something like that happens, right? Industrial accidents happen all the time. That is why they take extra measures to actually put in safety and everything, right? Hands-free way is a possible thing to do, right? But for industrial applications, it has to be 100% accurate. You cannot have a single error in it. You have one error, there is someone's life on the line. So that can be used for means like industrial, still in the work process. No one has ever deployed a hands-free till now in industries. They will put in robots and such like that. They interact with robots, but they actually do not directly communicate with the heavy machinery itself. So there is one library that we all like for hands, that is MediaPipe. That is way fast. MediaPipe hands works on almost 25 to 30 FPS on an i5 PC. So that's why we use MediaPipe hands. Gives us 20 points. Can compute almost what do you say? This has also some different models that you can use for some optimized architectures. Like anyone use Luxonics OP? Like this is a stereo camera that we use. They also have a module called. Have you used that? Okay. So yeah. So when you are working with 3D cameras, then also MediaPipe is your solution for that base pose. Works the same. Highly optimized for hardware. Okay, let's run into some demo. So first of all, we'll be looking at the pose estimation demo. So for that, we'll be the most pose estimation demo you have looked at through LinkedIn or you have looked through is a health monitoring system, right? A push-up counter. So for the push-up counter, we used actually YOLO V8 for that. YOLO V8 right now is the state-of-the-art model, and the pipeline for that is also very easy to actually use. So if you look behind me, so there's a guy that's doing a push-up, right? So the push-up counter right now is 0. See how it changes. So can you determine like how are we counting it? Looking from the image, looking at the key points. What do you think is the deciding factor we are doing for doing a push-up counter? Yeah.
Maybe angle between the shoulder and the
Yeah, the hand points, right? This, and this, right? Yeah. So that is being used. So we are using the average angle of them. Now let's do a quick demo of. Any questions regarding this demo? Okay. Now we have a demo of an hand gesture. Just a minute.
Can you zoom the code?
Yeah. Just give it a second. I think there is something. कैमरा चालू करना पड़ता है
कोई नहीं कर देना
वो भी इसमें ये वाला कैमरा चालू है
जब ये रिकॉर्डिंग मतलब कैमरा
उसको फर्क नहीं पड़ता आई नीड दिस कैमरा इज ऑन व्हाई इज दिस ऑन
रन होगा ओके
हाँ वही मेरे को लग रहा है
आराम से ये उसमें कोई दिक्कत नहीं कोई दिक्कत नहीं इसका कैमरा वर्क नहीं कर रहा है शायद ऐसा
नहीं इट इज वर्किंग बट समवन
कल चेक किया था
yes see this light is working
something is using it right no issue
someone else is using it
right मैं समझ गई
but who is using it
क्रोम को उसमें नहीं
बंद है
राइट और दूसरा क्रोम को दो विंडो है ना
क्रोम में दूसरे में ये है
क्या है
क्या बोलते हैं वो स्टॉप शेयरिंग वाला वो लगा
वो छोड़ दे QR कोड
क्या ये कोड है
उसमें और कोई टर्मिनल ओपन है
अभी तो जस्ट चल
ओके तो कैमरा का वो चीज़ ओपन करके पता चल
हाँ
चीज़
एक काम करता है ना
बोलना
एक सेकंड नहीं कैमरा ही बंद कर देता है कैमरा बंद कर दिया अब कोई खोलेगा तो जीरो पे ही है ना कैमरा खोल देता हूँ चीज़ खोल ही देते हैं ना
चीज़ को
वन वाला भी है जीरो आप तो चालू करना पीछे देख okay can you see the dashboard down there on the back so it will detect both hands but only the bounding box is our original one right so if you look at it so this is a dashboard that we created right with where you can draw stuff right so let's say I put it on my finger so this draws a line so one finger put it two finger I can select what I have right now I can change the color I can move it up and select 3 I can make an eraser out of it I see that media pipes runs quite fast, but right now it's not because I already have streaming and some stuff already going on. So this usually works at 20 FPS, 20 to 30 FPS. Okay. So this is one of the use cases that you can do. Like you can make interactive sessions on your YouTube. Like one of the most interactive sessions on YouTube you can ever find is whenever someone is teaching, right? They are actually behind the board. They have a transparent board. They are actually behind the board, and they write actually opposite. Right? So you can make stuff with this also. Like you want to draw or make an interactive experience out of it. So here if you look at it, so how is it working? So we have 5, 1, 2, 3, 4, 5, and we get the positions out of it. And like if we do this, so all the points actually come down, and this one is a bit up, right? So that's how we detect it. So these are like application level codes that you can write whatever you want to do, right? You want to do something, let's say, like we draw something out of it. Okay. I want to clear it. I want clearing functionality for it. So any functionality you want, any application that you want to develop, you can. Those are application level code, right? So yeah. Any questions? The dashboard, anything of the session. Yeah.
Actually, I use the same hand detector to make an adjusted mouse.
Media bit.
Yes.
Yeah.
I saw in your code that you have set the detection count to 0.75.
Yeah.
I have set below 0.9 and it actually detected my food also. Is it still a problem in that?
0.9 and then it detected your food.
Yes.
Yeah, there are cases. There are cases like let's say when you have lighting conditions are different, those kind of things. Media wave is fast. Media wave is not accurate. It's fast. It's one of the fastest. So if you want to, so basically when you want to do hand stuff, right, for media pipe, it is obviously suggested you do not run hands directly. First of all, run a detector out of it. Means like it has a detector, but still don't use. It's not useless. And the data that you send in media pipe hands is the raw data, right? Instead, what you do? Run a detector pipeline out of it. Get your hand, especially by using a good pose model. Okay, and then take a section of the hand, put it into good lightning, put it into deep blurring, and run some pre-processing on that, and then send it to media pipe hands. It's a very good thing. Media pipe hands is fast, but media pipe hands has this problem because in low lighting conditions, let's say whenever you do two hands, it works on that. Let's say I'll put my finger out of it, it's gonna get detected also. It's not detecting right now, but sometimes it does. Maybe due to lighting conditions, but it does. Sometimes it has already. It's like I put it here, and so I had 3 fingers here and 2 fingers of this hand. So that happens. This is computer vision. Like this is AI. You are never gonna be 100% accurate, right? Because we are computing values like linear algebra to estimate a thing, right? So you put in pre-processing, you put in post-processing to make it accurate, right? Depends on the application logic and the business logic, right? Any other questions?
Great guys, that was a great session and